Welcome to the first session of Lightning Talks on Fairness in AI Systems. I am Amit Sharma, Senior Researcher at Microsoft Research in India, and I'll be your host. These short talks will give you an overview of the work on fairness in AI systems at Microsoft. The speakers will highlight how they've been using and applying fairness principles in real-world AI systems. In particular, we will look at measuring and mitigating different kinds of fairness-related harms in vision, speech-to-text, and natural language systems. With that, please welcome Michael Amuoko and Kristen Laird to kick us off.
I'm Kristen Laird, joined by Michael Amuoko, and we're both Responsible AI Program Managers at Microsoft. In this talk, we'll talk a little bit our approach to fairness, and then we'll talk about how we're trying to develop products responsibly and enable customers to use them responsibly. Both Michael and I are from Cognitive Services, which offers pre-built AI models that range from vision to speech to language to decision. But in this talk, we're going to focus on our speech-to-text service specifically. There are several ways of thinking about responsible AI, and Microsoft has a very comprehensive approach that covers 6 different principles. But one of the ways that we've been breaking this down in Cognitive Services is into 2 buckets. How do we develop our products responsibly? So what sorts of fairness assessments and mitigations do we need to do? And how can we enable customers to use them responsibly by being transparent, communicating characteristics and limitations, and in some cases, making certain technology limited access? Specifically within responsible development, fairness is one of our top priorities. There are different types of fairness-related harms that we consider, but one of the most salient for speech-to-text is quality of service, which measures whether or not the service performs as well for some people as it does for others. When we're considering quality of service fairness, there are several steps involved. First, we need to identify the priority factors and groups, where a factor is something like age, gender, or nationality, and the groups are the subgroups within that factor. So with gender, for example, it may be men, women, non-binary, and other gender identities. Next, we assess for fairness-related harms. Based on our testing and careful data collection, do we notice any disparities that we then need to mitigate? It's also important to reassess on a regular cadence and make this just part of engineering excellence. But the process is only complete if we also communicate some of those characteristics and limitations, which ties into the responsible development practices that Michael is going to talk about. Currently, our speech service tests a variety of factors and groups, ranging from different languages to genders to different ages to different accents and nationalities. And we're on a continual journey to improve, as this particular study highlighted. And this became one of our top priorities. As we considered how to apply our quality of service approach, it became clear that we needed to design our data set and our test sets extremely carefully and go back to the drawing board to consider what are all of the different factors that may impact the way in which somebody speaks. So there are a variety of different factors that impact speech, ranging from age to geography. And when we think about designing a data set for a fairness assessment, we need to consider both confirmatory factors and exploratory factors. A confirmatory factor is one where we already know that that factor impacts performance, and we have to prioritize certain distributions for that in the data collection. An exploratory factor might be something where we don't have evidence yet that it impacts performance, but we hypothesize that it might. So we still want to collect at least some metadata about that factor so we can incorporate it into our analysis and our troubleshooting and potentially prioritize it in future data collections. As we went through our own data collections, we've had a variety of learnings. And one of them was the difference between some of our expectations and reality. We went into some of these data collections knowing that it was important to have careful design And it still turned out that we needed even more expert input and community input than we initially expected. For this data set, it turned out to be crucial to have expert input ranging from sociolinguists to fairness experts to community members. But designing the collection is only half the story. It's also important to consider how we actually conduct the collection. And getting that expert input, which is a best practice we highly recommend, impacted everything from the tasks that participants saw, to the screening, to even how we messaged them. So that's a high-level overview of just some of our fairness responsible development practices, and I'll turn it over to Michael for responsible use.
Thanks, Kristen. So as Kristen mentioned, I'll be talking about responsible use of AI, starting with responsible AI documentation. So a big part of how we try to help our customers use our services responsibly is by including documentation that outlines the different guidelines for using a service. So that ranges from use cases and key considerations to things related to privacy and security. Beyond documentation, we also aim to offer tools that customers can use to understand fairness in their own context. The specific tool that I'll be discussing is called FairLearn, which offers algorithms and methods to do a disaggregated analysis of a service or system. And in this case, I'll be doing a walkthrough of a speech service, for example. So one of the first things to think about in sort of using FairLearn or using a fairness assessment tool is the data. So in a speech data set, there'll typically be a common passage that the readers are instructed to read. And there'll be metadata that includes things like age, native language, country, and as the person performing the assessment, you're choosing which of this metadata you want to assess fairness along. So in this example, I'm showing results on countries. And so here we're looking at raw word error rate values. And so each of the values are positive, and the passage itself is what has been compared to the output of a speech-to-text system. But I also wanted to note that typically you should compare the human annotation of the speech to the predicted text. That way you're fully capturing what the speaker said as compared to the prediction. And another way to think about this is in terms of disparity from a chosen benchmark. So for this example, I use 0.5 as the benchmark. And that's why you'll notice that some of the values are negative, meaning that they're below this benchmark, and some of the values are positive, meaning that they're above that benchmark. And this could be another useful way to think about fairness. Lastly on this, within FairLearn, you can think about data distribution, which can give you some insight into how reliable each of the results are. So in this data set, for example, we had majority English speakers, and so that's where we might have the most reliable results, versus smaller groups might have less reliable results in terms of the values. So other things to consider are combinations of features. So if you were to look at country and age, for example, you might get some different insights. Consider thinking about whether it might make sense to compare word error rate against some chosen benchmark as opposed to comparing the raw values, and also consider the role of the data distribution. So overall, in terms of considerations for both us at Microsoft and our users, it's important to carefully think about data set design and the factors that you're looking to consider in the collection. It's important to seek input, as Kristen mentioned, not just from subject matter experts, but also from members of the relevant demographic groups. It's important to assess and communicate the limitations of the system, and ultimately to make responsible AI part of the engineering lifecycle. And as I said, these are our key learnings and insights. And thank you guys again for attending our talk.
Hi, my name is Solon Brokus, and I'm a principal researcher at Microsoft Research. Today I'll be presenting some joint work with colleagues at Microsoft Research on representational harms in image tagging, specifically when computer vision models are used to automatically tag images. Computer vision is used for image tagging across a range of applications. For example, Microsoft uses it to automatically generate alt text in PowerPoint, textual descriptions of images for blind and low vision users. It is also an increasingly common feature in photo management software, which allows users to search by keyword even when they have not manually annotated photos themselves. Over the past few years, however, there have been growing concerns about these applications and the harms that they might cause. This research attempts to catalog the potential harms of image tagging systems, and we provide concrete examples of each type of harm, considering the measurement and mitigation techniques that might help to identify and address them. Our work builds on previous research in which we drew a distinction between allocational and representational harms. Allocational harms are the traditional focus of research on fairness in machine learning, where researchers tend to worry about the way that machine learning might affect access to important opportunities and resources, such as jobs, admissions to university, or loans. In contrast, representational harms occur when the behavior of a machine learning model affects the understanding, beliefs, and attitudes that people hold about specific social groups. For example, when Professor Sophia Noble demonstrated in her book, Algorithms of Oppression, that image search results included pornographic content for the query black girls, but not white girls. We argue that such model behavior is harmful because it reproduces unjust social hierarchies in which members of certain groups are cast as subordinate or less worthy of respect than others. We caution against reducing concerns with fairness in the context of computer vision to mere disparities in model performance across groups or to instances of model behavior that happens to offend a particular individual. In our work, we are concerned with image tagging that systematically affects people's understanding of specific social groups, and as a result, these groups' standing in society. In our full paper, we outline 6 distinct representational harms in image tagging, but given my limited time, I won't be able to go into depth about all of them. I do want to discuss a few and offer some key takeaways, however. First, I want to show how our taxonomy helps to highlight the fact that different harms call for different measurements and mitigation techniques. Consider stereotyping as a distinct harm. You might think that we can capture such harm by examining differences in the error rates for similar images containing members of different groups. For example, we might want to investigate the degree to which image tagging systems incorrectly tag women doctors as nurses, and ensure that the accuracy of such classifications does not vary regardless of the gender of the person in the image. That said, we might also want to examine whether images that we perceive to be the same, but only varying the identity of the people who appear in them, do not receive a different distribution of tags, even if those tags are strictly accurate. Researchers have shown that image tagging systems are more likely to remark on women's physical appearance, while men are more likely to receive tags describing their occupation. Now let's consider cases where image tagging systems might be demeaning. Obvious cases include the use of explicit racial epithets, cases actually that researchers have shown on a number of occasions. But cases of demeaning behavior can be more subtle, as when a system returns the tag Halloween costume for an image of a Native American headdress. While there's nothing inherently objectionable about the tag Halloween costume in comparison to a racial epithet, the application of this tag Halloween costume to this particular image is demeaning because it trivializes the native dress of the American Indians. Identifying and anticipating demeaning behavior is much more challenging and much more open-ended because it requires considerable cultural and historical understanding. Our taxonomy also helps to reveal that some obvious mitigations for certain harms may be in tension with another. For example, some harms are caused by the inclusion of certain tags, while others are caused by their absence. The first 2 harms in our taxonomy focus on the harms caused by the imposition of identity categories onto people given their appearance. Gender classification, for example, assumes that gender is always visually evident, that there's a clear and consistent mapping between visual appearance and gender, and that gender can be unproblematically assigned to people without their knowledge, consent, or participation. Such practices raise concerns about the freedom that people have to self-define and the degree to which membership in certain social groups is assumed to require a certain appearance. And thus we might hope to mitigate that harm by refusing to engage in gender classification at all. At the same time, the failure to explicitly name the groups that have suffered some injustice due to their membership in a particular group can be harmful as well. Tagging the final image, for example, with people and walking fails to acknowledge the unique struggle faced by women suffragists. In this case, avoiding the harm requires naming the group whose identity is at stake. Our work highlights that different harms call for different measurement and mitigation techniques, and that any mitigation technique developed to address one harm may, unless taken with care, exacerbate another. Thanks very much.
Hi, I'm Chadatullah. Today I'm going to be talking about SAVI, a method for measuring fairness-related harms in natural language services. So first things first, we need to get some background. Let's talk about fairness and language models. Language models are based on text written by humans, and societal biases are inherent to human language. So naturally, those biases are reflected in the text datasets. Then we take those datasets and train language models on them, and the models internalize that unfair behavior. Now, it's one thing to have a unfair model sitting in a silo, but what's happening increasingly these days is large companies taking large language models and building natural language services. Think something along the lines of a service completing your sentences while you're writing an email. Now, when that happens, we have real users interacting with these models, and that unfair behavior can cause real psychological harm to those users. Now, this is a very serious problem, and we need to address it. So, how do we approach addressing these fairness-related harms? We typically need to identify the harms and the patterns. We need to measure, and then we need to mitigate. The measure and mitigate side of these things is very familiar to natural language service practitioners and language model developers. But the tricky part here is that we're dealing with a socio-technical problem. This problem really straddles the human experience and the technological aspect behind language models. So the measure step is actually lacking good prior methods. We need to come up with a new solution. So what we need to do to design a good solution is take the best of both worlds, from the computer science and the social science side of things. From the computer science side, we like some principles from test sets and unit testing. From the social science side, we really need to borrow that user-centric framing, thinking about the humans who are at the other end of the service and can cause this psychological harm. We need to protect them and center on them. Then measurement modeling acknowledges that when we create metrics for a theoretical construct, we're really making a proxy. And the measurement modeling lens asks practitioners questions about whether your proxy is reliable and valid. So given those best of both worlds inspirations to draw upon, we come up with 5 principles for SAVI. Scalable, automated, valid, interpretable, and inclusive. Scalable because we are borrowing that user-centric framing, and when the same language model is served under the hood in different products, but the different product scenarios have slightly different user experiences, we actually need to create unique, tailored solutions for measurements in each of those scenarios. Then automated, when the resulting measurement is created, we need the practitioners to be able to quickly decide if model A or model B is going to minimize risk of harm for their users. Then valid. This revisits the measurement modeling lens. When you created that proxy to measure fairness or stereotyping, did you do it well? Is the resulting measurement actually approximating this harm and measuring what you intend it to? Interpretable means that we're going to avoid using black box machine learning to measure fairness-related harms in our other black box language models. And inclusive here is the most important. It means that unless we as practitioners collect the lived experiences and document the lived experiences of all possible people who could interact with this system, we are going to be excluding certain marginalized groups, not accounting for them in our measurements and mitigations, and furthering the fairness-related harms to those groups of people. So we need to include and center on those individuals when we are creating our measurements. So that brings us to the Savvy process. The Savvy process from a bird's eye view is lifting, transferring, and discussing. When we lift, we combine the identified harms and patterns of harms that we've taken from those inclusive conversations with users with the product expertise, understanding how the models work under the hood and how the user experience flows. Then we lift and we transfer. We transfer into building a data set, building a scoring mechanism, and a metric for the product side. Then we have to go back to the social lens and discuss the measurement modeling validity and reliability. By leveraging the best of both worlds here, practitioners can create well-principled measurements that protect users from natural language service harms. Thank you.